Cool. So, hello everyone, and welcome to this workshop on the Flare data connector. This workshop is titled "Bring Any Web2 Data on Chain." So, first of all, what this workshop is about? It's about the Flare data connector. This is an enshrined oracle on Flare that allows you to do, well, many things, but the one that we'll be focusing on today is bringing any Web2 data onto the Flare chain. And, well, the main advantage of that is that the data brought on in this manner can be trusted because it's done so by all of the Flare validators, also called data providers. So I think I'll just start with the example. What we'll be looking at is Star Wars API. We'll be looking at the second link, and I think I can also zoom this a bit. So this is a simple API that allows you to query Star Wars data, and one we'll be interested in specifically is the one for people. So what you can do is you can go to this URL or post a GET request to this URL with a ID appended to it. So for example, if we query Star Wars API.info API people-1, we would get Luke Skywalker. And so what the Flare data connector will allow us to do is get some of this data onto the Flare chain. So what we can also do, because the data in this shape might be useless, there is a lot of data, we don't need all of it, it perhaps isn't even in the correct shape, so what we can also do is modify it, or modify it by passing it through a JQ filter. So I'll open up a website called JQ Playground. This is basically a website that allows you to preview how your JQ filter would behave. So if I just copy the data here into the JQ filter field, and I think I also need to remove these two characters, then it will allow me to, for example, do name equals dot name, and yeah, you can see that we can get field values out of the JQ very simply. But JQ is also a more powerful tool than just this. We could also get something more complicated, and for that I'll just take a pre-prepared example and I'll paste that in. Okay, cool. You can see that I've just been copying and pasting this from the Excel shell code, so it doesn't work out of the gate. But yeah, you can see that if we take the URL, split it over the / and take the second to last value from that array and convert it to a number, we can get the UID, the number 1. This is the thing that appeared in the URL. Or we could also get the length of the films array, which would then give us the number of films that the character is appearing in, and the number in this case is 4. So we can get a JSON response from an API. We can apply a JQ filter to it. The last part is storing it in a form of a solidity struct, which can be written on chain. And I'll speak to that in a second. So before we continue, before I run the code, let me talk you quickly through how the Flare data connector works from the user's perspective. So if I go to the Flare developer hub, and specifically to the FDC and FDC, I can find a diagram that demonstrates how the workflow for a user looks like. So, first of all, we have some external data that the user observes. In this case, that would be Star Wars API. And the user then desires to bring that data onto the Flare chain. Now, what the user first has to do is formulate a request in such a way that FDC can process it and fulfill it. And that can be done manually by hashing a few values or hex encoding a few values. But a more convenient way is just posting the data to a verifier server that is provided by the Flare network. And the verifier server will pop out the correct ABI encoded request, which we can then send to the FDC. So the FDC is a protocol that encompasses many things. It is enshrined into the Flare chain, which means that it is shipped with each version, with each node, so it is replicated by each validator. And I'll explain why that matters in a second. But basically, once we get the ABI encoded request from the verifier server, we can post it to the FDC hub contract on the Flare chain, and that will start the whole machinery in the background. So what will happen in the background is that our request will get spread throughout the validators, the data providers on the Flare chain. Each of them will fulfill the request, go to the URL that we have provided, get the data, and then crunch it together to get a proof, and only the proof will be written onto the chain. So then, in the next step, once the voting round has finalized, we can go to any of the data providers and request the data from them, and they will provide us with the data. And then we can do the same thing that the validators did, crunch the numbers, get the proof, and we can compare the proof that we got with the one that was written on-chain, and if they match, it means that they gave us the correct data. So in that case, we can minimize the storage space taken by the data by only storing the proofs for it. And then we can, of course, get the data off-chain and feed it into our contract as a proof, and the proof also contains, the proof that the data is valid. So in that way, we have trustworthy data on-chain, and we can feed it to our contract. So let's look at the code now. The code is already available in the Flare Hardhat starter on GitHub. This can serve as a base building block for your project if you decide to build on Flare. And I'll speak to how you can modify it in a second. But basically, what we have here is a simple Star Wars character list contract. And all this contract does, it stores some character data on the Flare chain. Oh, I should probably zoom in a bit. This contract has a mapping that maps a UID to a Star Wars character struct, and this is simply the name of the character, the number of movies they appear in, the ID on the URL that we provided, and a body mass index, which is, yeah, it's a bit funny. But I mean, the Star Wars the Star Wars API provides us with height and mass, so it's a fun thing that we can calculate for the character. And so the only function, the only important function in this contract is the add character function, which takes the Web2 JSON proof struct, which contains both our request, the data we requested, and the proofs that are written on chain. And from that, we can extract the character information. We can also verify that the proof is valid, and then add the character to the list, while we also calculate their body mass index. And there is also a utility function called getAllCharacters. Now, before I run the script, there's one last thing that might be worth paying our attention to, and that's the ABI signature hack function. So this is the easiest way so far that we've found of getting ABI signature of structs that we want to save our data as. So right at the top of the file, I have a data transport object struct with name, height, mass, number of movies, and API UID fields. And this is all the data that we want to extract from the Star Wars API website. And so I define a solidity struct and then pass it as an argument to the ABI signature hack function. And the reason why I do this is so that when I run yarn hardhat compile, I will get the contract artifact, and within the artifact for this contract, so let me just open that up. Within the artifact for that contract, I will also get the ABI signature hack function as one of the functions on this contract, and within its parameters or within its inputs, I can get the ABI signature of the data transport object, and so I can copy that and provide it to the verifier server as one of the components of the attestation request that we'll be making. So now let's run the script, and I'll explain what's happening as it happens. So let's just do that. So first of all, we are making a request to the verifier server with a few values that don't really need to be changed if you just take this code as base, but they are basically hex-encoded strings of, for the attestation type, I think it's Web2 JSON, padded to 32 bits, and source ID is public API, I think. Let's look at that. Public Web2 JSON. But that doesn't really matter. What's more important is, first of all, the URL is the Star Wars API. The character will be number 3, and you can guess which character that is. Then the HTTP method will be the get method. We won't be giving any headers or query parameters or a body, but the post-process JQ will take the character's name, their height, their mass, number of fields they star in, and the UID. And the ABI signature is the one that I showed you within the artifacts. And so we post that to the verifier server. We get a valid response, and this here is the ABI encoded request. And now we compose this ABI encoded request to the FDC hub contract on the Flare chain. We also need to calculate the voting round ID in which we posted the request, just so we can retrieve the data later. And so the machinery has run in the background. It never takes, it cannot take more than 180 seconds, though usually it's much, much quicker than that. But 180 seconds is the top, theoretical top limit. And so we prepare a request, and the proof is generated for us. So what we get is a response hex, and this response hex can be decoded into a correct solidity struct, which also includes the data that we wanted encoded as the data transport object that we defined. So the ABI signature that we provided is how our data will be decoded. And here are the proofs for that, for this request. And if we then decode the data, we get an error, apparently. Okay. Cool, very, very cool. I know what the problem is, but I won't be debugging this now. Unfortunately, what we were supposed to get is that the character number 3 is R2D2 with a body mass index of something above 30, if my memory serves me well, which qualifies him as obese, I think. So yeah, this is very quickly how the Flare data connector works. Now let's talk real quick on how you can modify the two provided scripts so that they can serve you as a base building block for your projects if you decide to build with them. So first of all, you would of course need to modify the contract that you will be deploying, that you will be using, and how this one is supposed to work. I cannot tell you because that depends on your project, but the only thing that it needs to contain is an iWeb2JSON proof and a function that can accept that as a parameter. And then of course, it's also useful if you define your own data transport objects so that you can get the ABI signature from that. The real modifications need to happen to the Web2JSON TypeScript script, which, well, first of all, you need to provide your own API URL with your own post-process JQ filter and ABI signature. And you can also tweak or play around with additional parameters. And there is an example on the Flare Developer Hub, as well as within this Hardhat starter, on how you can use the Web2JSON attestation type to, for example, get weather data and use that to automatically resolve the insurance policies that depend on the weather conditions. So this is the first thing that you'd need to modify, and then the second thing will be deploying verify contract. You might decide that you actually don't need this function. In that case, you would just replace it with a standard. You would just return your where's the thing so I can point to it. You would just simply what you would do is just create your take your instance type at a certain address, and that would be the correct thing. Okay, I see why now. Now I see why it might have been failing, and that's because I've been writing a guide on how you can modify this, and I have pasted in the modified version instead of the correct one. Anyways, yeah, you would just do return your contract type at, and you would provide the address. So that's the first part. If you wanted to deploy a new contract every time, you would of course need to replace the Star Wars character list v2 instance with your contract instance, and same for the other thing here. And then as for interacting with the contract, you could also define a more complicated way of interacting with your contract, but you would basically access it in this manner. Let me now just quickly discard the changes and try running the file again. Yeah, so that's really quickly on how the Web2JSON type works. Now let me just point you to a few useful sites. So the first one is of course the Flare Developer Hub. Here you can find guides, written guides for other attestation types. So if you go to FDC guides and hard hat, you can find guides for EVM transaction. This is an attestation type that allows you to get the data about an EVM transaction on XRP and two additional chains that are both flares. But there are also examples of how you can incorporate the Web2JSON type in a real-world scenario. So one is proof of reserves, which basically collects the state data of stable coins across different chains and compares that to the reserve amounts they claim they have. And the one that I find even more interesting is the weather insurance example, which is an insurance agency where you can create policies that can be resolved automatically depending on weather conditions at certain coordinates. And yeah, there are additional resources here at the Flare Developer Hub, and there's also the Flare Hard Hat starter, and that is a GitHub repository where you can find all the relevant example code, for example, for the thing that we've been doing here today. So that's very briefly what we do at Flare and how you can use it. I'll let the code run in the background, but I think I'll turn to you for questions. So, does anyone have any questions here? Well, if not, I'll just let the code run until its end, and hopefully this time it will work. I mean, the one on the Flare Hard Hat starter is supposed to be working. I think I've broken it when I was changing things around. Yeah. Anyways, if there aren't any questions, I thank you for coming to this workshop, and I wish you good luck hacking, and hopefully you'll decide to hack, to work on Flare for your project. Yeah, thank you.